Okay, y'all. So on Tuesday, we took notes on ionic compounds, and you should have copied this into your notebook. If you don't have this in your notebook already, then I need you to go back and watch part 1 of Ionic Notes, which I posted on Tuesday. It's called, like, Ionic Notes from January 31st, I think is what it's called. I need you to watch that video first and take all the notes in that video, because this video is going to be assuming that you've already seen that and written all that stuff down. All right, we're going to move forward from here now. So in that video, in those notes, we wrote down the charges of these monoatomic ions. So the charge of a hydrogen atom, the charge of a hydrogen ion, of a lithium ion, of a sodium ion. You can turn the sound on, it's okay. Magnesium, calcium, and we did some practice problems with these already, right? We did these in the last video. But it's going to get more complicated from here, I guess, because we have talked about monoatomic ions, but not all ions are monoatomic. First of all, what do you think monoatomic means? Let's see. Mono, we know that prefix now because it was in our covalent unit. We know that mono means one, and atomic means that there's one atom. So that's what that means. One atom, monoatomic. So in a beryllium ion, and a magnesium ion, calcium ion, sodium ion, all of these, it's just one nucleus in that ion. But there are also something called polyatomic ions. And I'm going to show you some stuff about polyatomic ions right now. So if you were following along with all of the Lewis structure practice, you would have seen that I asked you to write or draw a Lewis structure for this compound. And people in class, when they got to this example, they were asking me, what does this -1 mean? What does that -1 mean? And I was telling them, and I probably told you, that -1 means that we have a negative charge on this molecule, right? The whole thing has a negative charge on it, which meant that we needed to add one more valence electron, and that's how we made the Lewis structure work. That's how we gave everyone octets. But this NO3 1- has a name, and it's called a nitrate ion. Nitrate ion, this is one example of a polyatomic ion. And the ion looks like this. It's a nitrogen atom, double bonded to an oxygen atom, single bonded to another one, or single bonded to two more, I should say. And we can put those electrons on there like this. And this whole molecule is actually charged. So it's not actually a molecule, it's actually an ion. And we're going to use polyatomic ions. We're going to use nitrate and others to make ionic compounds. So let me show you what I mean. By the way, I do want you to write this. I do want your paper to look like mine still. So, for example, if we were writing the formula for sodium nitrate, which is a totally valid test question, then you would follow the same steps that we used in the first video, right? You would say, okay, what's a sodium atom? That must be a +1, because you're going to find that in your notes. And then nitrate, this whole thing is a nitrate, so I'm going to write NO3. It's a nitrate ion, and nitrate ion has a charge of -1. And now I'm noticing that these charges already cancel each other out, right? They add up to 0. So I just need one sodium ion and one nitrate ion. Now those charges cancel each other out, so I don't need to put a -1 up here or a +1 up here, because when they're together, now they're neutral. They cancel each other out, no more charges. And that is my sodium nitrate formula, right? So sometimes we're going to end up with charges that don't balance each other out. Let's do calcium nitrate. Calcium, now this one has a charge of 2 plus 2. Nitrate is still the same, NO3 minus 1. But now our nitrate does not cancel out all of the positive charge from our calcium. So we need to add another nitrate. All right, so when we go to write the formula for this, we can write CaNO3, NO3. Maybe you want to do it like that. Now, of course, like I've told you many times before, chemists are lazy, and so they would never write it like this. Even if it's technically correct, they're going to want to shorten that somehow. So they're going to do it like this. They're going to write Ca, and they're going to open a parentheses and put their nitrate in there and put a 2 outside of the parentheses to show that there are 2 of whatever is in the parentheses. In this case, there are 2 nitrate ions. And CaNO3 parentheses 2 is how we would write the formula for calcium nitrate. So this is our final answer. Okay, so that's calcium nitrate. Please do not write it like this, right? If you don't put the parentheses in there, well, now you're just saying that we have 1 calcium, 1 nitrogen, and 32 oxygens, which is way too many oxygens, because really we only have, 6, right? Because we have 3 in this nitrate and 3 in this nitrate. If I wanted to draw maybe like a Lewis structure for calcium nitrate, I would need to draw this twice, right? So I have 1, 2, 3, 4, 5, 6 oxygen atoms in my calcium nitrate, and I would need just 1 calcium ion, or 1 calcium atom. So there we go. That's how we would write that. Now, if we were only working with nitrate, that would make this super, super easy. But remember, nitrate is just one example of a polyatomic ion. There are more that I need you to know. So I want you to write these down too. Let's start a new section, call this common polyatomic ions. I'm never going to ask you to memorize these polyatomic ions, but I do need you to have these in your notes, so that way you can work with them in the practice problems. On the test, I'll literally give you a list of polyatomic ions and their charges, so that you don't have to memorize any of that. But let's write them down now, so we can start to get familiar with them. The first one is nitrate, NO3 minus 1. That's called a nitrate ion. The second one I want you to write down is CO3. This one has a charge of -2. This is called a carbonate ion. PO4 -3. This is a phosphate ion. And the last one that I want you to write down for now is NH4 plus 1. This is a polyatomic ion with a positive charge. And this is called ammonium. It's called an ammonium ion. And there we go. Those are the 4 that we're going to be working with in our examples today. So we already did sodium nitrate and calcium nitrate together. I want you to try, you can pause this video and try it yourself. I want you to try calcium carbonate. Give that a shot. Okay, so calcium is Ca, and I know that calcium has a 2+ charge because I look back at my notes and I find calcium has a 2+ charge. Carbonate, I just wrote it down, it's right here, has a CO3 2- charge. This is an example where our charges cancel each other out right away. So I don't need any subscripts. I don't need multiple of anything. So when I write the formula for this, it's literally just Ca CO3. Easy peasy. Try another one on your own. Let's try ammonium phosphide. Ammonium phosphide. Give that one a try. All right, here we go. So ammonium, we just wrote down as NH4. It's got a +1 charge. Phosphide, be careful. I hope you didn't write phosphate. That's phosphate. We have phosphide here. And phosphide, if it ends with "ide," then we know that that is just a monoatomic ion. So it's just P. And I know P by itself has a -3 charge. So this charge is bigger, so I need to add more of that. I need to add more ammonium. And I'm going to add 2 more. So that now my total positive charge is +3, and my total negative charge is -3. Those do cancel out. They add up to 0. So now I know that I have the right number of each ion, and I can put them together in a chemical formula. I can write NH4, but I have 3 of them, so I got to put the whole thing in parentheses and put a 3 there. And then I only have 1 phosphide, so I can write my phosphide like that. NH4, 3P. And there is the formula for ammonium phosphide. I'm going to do 2 more, I guess. Let's do calcium phosphate. And let's do magnesium nitrate. Or, no, it's kind of boring. Let's see, what can we do? Let me think. Oh, I know what we can do. Let's do aluminum carbonate. That's a good one. Aluminum carbonate. Try those 2, and then I'll show you the answers. All right, calcium, again, is a 2+ charge. It's always going to be a 2+ charge. And phosphate, that's PO4, 3-. Now, my calcium has a +2 charge. My phosphate has a 3- charge. These do not cancel out. And I'm going to need multiple of both of these, right? Because if I just add another PO4, right, now I'm at -6. And -6 is much bigger than +2. So I need to add some more calciums. And now that I have 3 of that and 2 of that, I have a total negative of -6 and a total positive of +6. These cancel each other out now. And so now I can write my formula. I have 3 calcium ions this time, Ca3. How many phosphates do I have? I have 2 of them. So I'm going to put parentheses, so I have 2 phosphate ions. And there we go. Remember, we could have also used the crisscross method here. Crisscross method is a super easy way to do these, right? But totally valid way also. The charge on one ion becomes the subscript of the other ion. Anytime you're a little bit unsure of how to make the charges balance each other out, just remember that crisscross method, right? And that'll work for you every time. Let's do aluminum carbonate now. Aluminum is Al, and it's got a 3+ charge. Carbonate is CO3, and the whole thing, the carbonate, has a 2- charge, a -2 charge. here you can see we can do the crisscross thing right away, and we can figure out that I need 2 aluminum ions and I need 3 carbonate ions. So I need to put this in parentheses like that, and there's my answer, Al2CO33. If you lean kind of mathy, right, and you're okay with some math, one thing that might be helpful is to think about taking the least common multiple of the charges. All right, so when I have a 3 and a 2, their least common multiple is 6. So then you need to ask yourself, how can I get 6 from this, and how can I get 6 from that? And you should be able to see 2 times 3 gives you 6, and 3 times 2 gives you 6, and that tells you how many of each ion you need. Right? You need 3 carbonates, and you need 3 carbonates, and you need 2 aluminums. You can also do it that way, least common multiple. But honestly, they're not really going to get much harder than +3 and -2, or +2 and -3. Occasionally, we'll get some ionic compounds that involve ions with a +4 charge, but those are pretty rare, and they normally work out pretty easily. Cool. So that's that. Remember crisscross, remember least common multiple, or remember just like kind of playing with it and adding more ions until you feel happy with that. So that's that. That brings a close to polyatomic ions and the polyatomic ions practice. Stay tuned for the video on practice for all of the monoatomics, or sorry, everything that we learned on Tuesday, plus everything that we learned on Wednesday. I'm going to be making that video as well, with some more practice in there for you. Remember, this unit and honestly chemistry class for the next while is all about practice problems and just doing a lot of practice. So it's going to look like this. Class is going to look like this for a while. We will get some labs again, hopefully soon, but we got to get through this somewhat dry period of just naming chemicals and stuff. Sorry, but that's the way it is. That's the way chemistry is. So hang in there. If you hate it, sorry. If you're liking it, good for you, because we're going to keep doing it. But yeah, stay tuned for the other video.